Hello and welcome to this Dr. Frost Maths key skill video on finding the angle sum of a polygon given its number of sides. Now we want to find the sum of the interior angles of a polygon with 5 sides, 6 sides and 30 sides. Now what do I mean by interior angles? Well, if I just draw any old pentagon, it doesn't have to be regular. It's basically saying we want to take these different interior angles, they're not necessarily the same, and we want to find the sum of all those angles. If it was just a triangle and we're adding the interior angles, the angles inside, then we know that the sum would be 180 degrees. We saw that in a different video. But what about a pentagon? What's the sum of a 5-sided polygon with 5 sides? Now there's a really clever little trick we can use here to find the sum, and then we're going to use that to produce a formula we can use for these other questions. And the way you do it is to divide your shape. If you take one point here, you divide it into triangles. So if I draw a line to this vertex here, this corner, and a line to this vertex here, can you see I've now got 1, 2, 3 triangles? And if I think about all the angles in these triangles, look, I've got this bit of this angle here, plus this angle, plus this angle. I know those angles add to 180 degrees. So I know the sum of the angles in this triangle is 180 degrees. The sum of the angles in this middle triangle is also 180 degrees. And the sum of the angles in this triangle here is 180 degrees. Now, I haven't created any extra angles. All these angles in each of the triangles make up the full angles, the full interior angles of the pentagon. So it must be that the total interior angle of the pentagon is going to be 3 lots of 180 degrees, and that's 540 degrees. Now, how many triangles can we get from the pentagon? Well, it turns out to be 2 less than the number of sides. So in this case, we've got 5 sides. 2 less than that is 3, and that means we can get 3 triangles. Indeed, that's what we've got. Now therefore the formula, if you have n sides, so the total interior angle, if there's n sides, we said we take the number of sides n and we take away 2 from it. That gives us the number of triangles. So 5 minus 2 was 3 in this case, 3 triangles, and whatever that number is, we times it by 180 degrees. So we times that by 180, and that will be the total interior angle. So let's apply that for B and C. So for B, we got 6 sides. To find the total interior angle, we do 180 multiplied by, because remember when things are next to each other in algebra, you just times them together, 180 times by n minus 2, 6 minus 2. So we just need to do 180 times by 4, and that's 720 degrees. Let's just see that formula in action. If I draw a hexagon, and I just take one point here and draw triangles, you can see there's 1, 2, 3, 4 triangles, each with a total angle of 180 degrees, and that's what we did, 180 times 4. So the formula works. And then finally, for C, we got 30 sides. Applying this formula, 180 multiplied by, I don't actually need that times symbol, n minus 2. So n is 30 here because it's 30 sides. So 30 minus 2, and I definitely can't do that in my head, so I'm going to use my calculator. 180 multiplied by 28, and that is equal to 5,040 degrees. That's the total interior angle of a 30-sided polygon.